Okay, once again, this is chapter 1316, Trigonometry, chapter 3, section 2 this time. I'm David Diffel from Lone Star College, Montgomery. In section 2, we're going to be working with what's called radian measure. If S is the arc length, for instance, if you start at a point and walk along the curve of a circle, that's called the arc length, because you're making an arc and you're walking along that length. The angle in the middle is the ratio of the arc length divided by the radius. So it's a fraction. And it's not going to come out in degrees, it's going to come out in what we call radians. Now suppose you want to find the angle. If the radius is 3 and the arc length is 6, you just take arc length divided by radius. Again, just take this formula, S divided by R. So your angle theta is 6 divided by 3. And 6 divided by 3 is 2, but we call that radians, not degrees. So if there's no degree symbol, you are in radians. Now, what's the angle of a half circle if the radius is 2? Well, we need to find out how far it is around half of a circle. A whole circle, the circumference is 2 pi r. Half of a circle, going to get rid of the 2, so it's just pi r. And since our radius is 2, we can substitute in 2 for this r and get 2 pi. So this is our S, our arc length is 2 pi. Now we plug it into this formula. Theta is S divided by r, so theta is equal to S, which is 2 pi, divided by r, which is 2, these two numbers here. And 2 pi divided by 2 is pi, so it's pi radians. Now suppose we want to convert from degrees to radians. That's two different types of measurement in a circle. We know 180 degrees is halfway across a circle. And we know pi radians is halfway across a circle, because 2 pi r is the whole circle. So half of a circle is just 1 pi. So we have 180 is pi radians. If you were to multiply the fraction, if you move this 180 on this side, you get pi radians divided by 180, and that's the fraction we're going to multiply by. So if you take 45 degrees and multiply by this fraction right here, 45 times pi divided by 180, you should get pi over 4, because 45 goes into 180 4 times. Okay, if you want to convert 225, take 225, multiply by pi, divide by 180, and 45 goes into 225 5 times, goes into 180 4 times, so it's 5 pi divided by 4. 150 degrees, take 150, multiply by the fraction, pi over 180. The degree symbols cancel, the zeros cancel, 15/18 turns out to be 5/6, which is 5 pi over 6. So to convert from degrees to radians, you multiply by pi, divide by 180. Now, suppose you want to go the other direction and convert from radians to degrees. You just flip over your fraction. Again, you start with 180 and pi. They're the same. Move the pi over to the bottom this side, and you get 180 divided by pi. Now, since we have pi and 7 pi over 6, we're going to take 7 pi over 6 and multiply by 180 divided by pi, so the pi's will cancel. We want a degree answer. If you put the 180 in the bottom, the degrees go away. So to get the degree to come in to our answer, you put it on the top. 7 times 180 divided by 6 should be 210. And again, the pi's cancel. 3 pi over 4, multiply by 180 divided by pi. 4 goes in 180 45 times 3, it's 135, and again the pi's cancel. Negative 2 pi over 3, that's going backwards around the circle, or clockwise. Negative 2 pi over 3 times 180 over pi. Again, the pi's cancel. 3 goes into 18 60 times 2 is negative 120. But you can also multiply 2.6. Don't forget there's no degree symbol here. It's just 2.6. That's the key to know you're not in degrees, you're in radians. There's no degree symbol. So you're going to multiply by the same fraction, 180 over pi, and you're going to get some decimal. In this case, it rounded off to 149. It was 148.98 or something. So it just rounded off to 149. So you can just multiply and leave the decimal. Now, when you're working in WebAssign, suppose they're going to say things like use 240 degrees, sketch the graph, find the reference angle, convert it to radians, and find the reference angle in radians. So let's go through that. Suppose you want to sketch the graph of 240. Well, 240 is going to start at 0 and go all the way around. 240 is in the third quadrant, so you're looking at somewhere over here, past halfway. The reference angle, 180 from 240 is 60. 240 minus 180 comes out to be 60. Convert this to radians. Well, it has a degree symbol, so we multiply by 180, or pi divided by 180 rather. You want the degrees to cancel. 240 times pi divided by 180. Degrees cancel. The zeros cancel. 24/18 comes out to 4 pi over 3. And then the reference in radians. Well, here's our reference, 60. You can take the 60 and convert it, or there's a much faster way. Since it has a 3 in the bottom, pi over 3 is going to be your reference angle in radians. Radians are real nice because their reference angles always end in whatever's in the bottom. So it's, get rid of the 4, it's just pi over 3. Okay, 60 degrees, you could have multiplied by pi divided by 180. It comes out the same thing. And suppose we start with a radian angle, 11 pi over 6. If we're going to sketch the graph, 11/6, if you take a circle and divide it into 6 pieces, not very neat, but it'll get done. Is that right? 1, 2, 3, 4, 5. Yeah. Okay, so we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's right here. There's my 11 pi over 6. Way down in the fourth quadrant. Your reference angle, subtract from a whole circle, which is 2 pi. So 2 pi minus 11 pi over 6. Well, 2 is 12/6. 12/6 is 2 pi. Minus 11/6 makes pi over 6. So that's my reference angle. That's how far I am away from the whole circle. That's only 1/6 because there are 11. One more makes 12. Okay, if I convert this to degrees, 11 pi over 6 times 180 over pi. That's my conversion. I want a degree symbol. Pi's cancel. 6 goes into 183 times. Should be 330. And the reference angle in degrees, well, 330 is 30 degrees away from horizontal. 360 minus 330 is 30, or you can take this pi over 6 and convert it, do it that way. Pi over 6 times 180 over pi, those cancel and you get 30 degrees. So you can either just find how far is 330, or you can convert your reference angle that we found before. So that's what you need to be able to do in WebAssign. And again, we're in section 3.2. This is Math 1316, Trigonometry. I'm David Dippo from Lone Star College, Montgomery, and this is my email address if you want to reach me. In Chapter 3, Section 1, we start dealing with reference angles, and that is the smallest angle between the terminal side of an angle and the x-axis. For example, if you have 127, starting at 0, going out 127 degrees, we're looking for the shortest distance from this terminal side down to the x-axis, or the horizontal. So we take 180 and subtract 127. 180 is the whole thing, subtract the 127, so what's missing is 53. If we look at 44 degrees, it's its own reference angle, because that is the shortest distance from 0, the horizontal, up to the angle, so it's 44. If you look at negative 220, going around clockwise, going down and back up, this whole thing, if you want to get to the horizontal, you're taking 180 from 220, and that will leave how much positive is left, which is 40 degrees. And then 251, if you start at 0, go around counterclockwise to 251, which is in the third quadrant. If you need to back off 180, so it's 251 minus 180. So this, going back to the horizontal, is 71. Now, to find the uses for the reference angle is, suppose you want to find the exact value of sine of 240. Rather than memorizing the sine of 240, you find the reference angle. Now, 240 degrees is in the third quadrant, and so sine is negative. Both sine and cosine are negative. And so the reference angle we look at is 60 degrees, because that's the reference. 240 minus 60 is 180. So it's going to be negative sine of 60. We've memorized the sine of 60, so it's negative square root of 3 over 2. Okay, suppose you have tangent of 330. Tangent is in the 330 rather is in the fourth quadrant. Tangent is in the fourth quadrant is negative. So we have negative tangent, and then we just deal with a reference angle for 330. And 360 minus 330 is 30. So you have negative, you have the tangent of 30, and the tangent of 30 is sine over cosine, which is, so it's negative 1 over square root of 3. So you can use your reference angles and which quadrant you're in. Again, if it was sine in the third quadrant, it's negative, so it's negative sine. Find the reference angle for 240 was 60. Reference angle for 330 is 30. Just subtract 180 or subtract 360. And those are the ones we've memorized, so then it's just a plus and a minus in front of what we memorized. Okay, now using a calculator, find where tangent is negative 0.8541 in the second quadrant. If you push inverse tangent of a negative number, it should give you, I believe, a negative 40.5. So I mistyped that. It should be negative 40.5. So then, so the tan inverse of negative 0.8541, that's why. Again, those are both negative. When you do that, negative 40.5 degrees, that is in the third quadrant. And we want to be in the, fourth quadrant. We want to be in the second quadrant. So we take our 180 and subtract 40.5. So to get back in the second quadrant, and subtract the 40.5, which should have been negative again, and you get 139.5, which is in the second quadrant. So let me put those negatives back in there for you. This was negative. When you used a calculator, it was negative. So you take 180, subtract the 40.5, which came from the calculator, to get back in the second quadrant. Now, we want to find out where secant is 3.8637 in the fourth quadrant. Secant comes from cosine, so just flip it over, and then you'll have cosine. If you flip over 3.8637, 1 divided by that number, you get 0.2588. Move the cosine over with cosine inverse, so you get theta is cosine inverse of 2588, which should be 75 degrees. Now we want to be in the fourth quadrant. 75 degrees is in the first quadrant. So you take 360, subtract the 75 to get down in the fourth quadrant. So we're starting in the first, and you want to back down to the fourth to subtract from 360. So we're going to either add or subtract from 180 or 360 to get where we want to go. And that concludes section 1 of chapter 3 in Trig.